Righto, we're back. Now, as you know, we have this cute little character, this Delhi boy, who's who has no animations. So now it's our turn to build animations for this guy, and I want to build these animations from absolute scratch. So I'm going to press escape, and what I'm going to do is I'm going to go to my content folder. I'm going to go to my Delhi man folder. I'm going to take the character, right? I'm going to right click the character, create animation blueprint. So we're going to create an entirely new animation blueprint. We're not going to use the previous one. I'm just going to call it Delhi animations, right? That's it. Just going to have a very simple animation blueprint. Like I told you, a skeleton has a skeletal mesh. A skeletal mesh has animations, right? You need to understand that relationship between the three things. So let's go back to our third person BP. Let's go to our blueprints. Let's open the third person character. Let's go to the viewport. Let's figure out the mesh. And what we're going to do is for the animation mode, we're going to use an animation blueprint. And the class that we're going to use is our Delhi animations, right? You can compile, and we're going to hit save. So when we play, nothing's going to change because that animation blueprint is currently empty, right? So what we have to do, let me just get back on top. So what we have to do is not just change the animation blueprint here in the viewport and the mesh, right? We also have to actually edit the animation blueprint, right? Which is go to our Delhi man and open the Delhi animations. We have to edit this. Now, one thing I need to kind of remember is that when you have an animation blueprint, especially when it's, let me just show you the third person blueprint, hang on. Right? And this is something that's just, it's nomenclature, it's like naming, which is in the mesh, when you have the anim class that you choose and you open that animation blueprint, there's an _C that's added, right? I just want you to remember this. It's added automatically by Unreal just to show that it's an animation class, right? So now I'm opening my animation blueprint, and as you can see, we have two parts like we've spoken about before. We have the event graph, which is completely empty, and we have the animation graph with an output pose, right? This is how a blank animation blueprint looks. So what I'm going to do is I'm just going to take the running, right? Just drag it here, and I'm going to put in the result, and I'm going to press compile, right? And as you can see, the guy is running, right? I'm going to press compile and I'm going to press save, and he's going to run no matter what. So if I press play, you'll see that the guy is running no matter what. It looks realistic only when you're actually running around, but when you're not running, he's still running, right? So we've got our animation blueprint working, but there's only one kind of output which is running. Now, if I choose some other output, suppose I choose hook punch, and I drag this here, you'll see that only one of the two works. You can't have both working at the same time. You can't have both feeding into the output at the same time. And if I press save and play this, you'll see that he's punching no matter what, right? So that's what we're going to do. We are going to work on creating a good kind of output for this player, where depending on the state that he's in, if he's walking, then well, we show that he's walking. If he's running, then we show that he's running. If he's punching, then we show that he's punching. So that's what we're going to do. And the way to do this is to calculate the state of the player. So we have different variables. We're going to create new variables. And depending on those variables, we are going to put this player's animation in different states, right? So let me show you what that means. So what we're going to do is we're just going to right click and type state machine, right? Add new state machine. So we're just going to drag from this to this. I'm going to press compile, and you'll see that the player goes back to doing nothing again. Now there's nothing inside the state machine. So I'm just going to double click, and now we are inside the state machine. So you've got this anim graph, and inside the anim graph, you've got the state machine. So in the beginning, we want to have a state called idle, right? So idle is basically the character is doing nothing, right? So now we don't have an actual idle animation. I forgot to download that. So let's go back to Firefox. Let's go back to Mixamo. I'm sorry. I use the Firefox browser. And let's look for idle, right? Let's see what the idle animation looks like. No, we don't want that. We just want the guy to do nothing. Yeah, this is good. I'm going to download this without skin. Save that. And we should have the idle here. So I'm just going to drag this into Unreal. Just to minimize this, let me just drag. Let me go to the right folder actually. We want everything inside the Deliman folder. So idle, pull this in and drag it in. Everything as we've always kept it. Now we have the idle animation. Now I'm going to go back to our animation blueprint. And in the idle, what I want to do is I want to double click. And as you can see, all the animations related to a particular skeleton are automatically added to the asset browser. So we just added idle in, it automatically comes in. So I'm just going to say, play the idle animation. So I'm going to compile and save. And as you can see, now there's an idle animation playing. And that's the only state that we have. So if you go to anim state, or if you go to anim graph, you see that the state machine, which is feeding into the output pose, the only state available is idle. Right? So press play, and we see that we have the idle state. So he's moving a little bit. You can see that there's some sort of breathing animation. It's very subtle, but it's good enough for us right now. So let's go back to our animation blueprint. We've got the idle state. Now let's add one more state called walking/running. Right? So depending on the speed of the character, we'll either do a walk or we'll run really fast. Right? So we'll say that we'll just move this. I just want to move this a little bit. Yeah. Yep. Okay. So one thing I want to do is I want to first make sure we have some sort of variable for the speed. Right? So if I go to event graph, I'm going to create a new variable called speed. Right? I'm going to change this value to a float. Now I want to get the actual speed of the character that's moving, right? And to do that, I actually need to call the character. So there's this thing in the animation blueprint in the event graph called try_get_pawn_owner, which basically gets the details of the character without you having to cast to the character. They know that you're often going to require stuff from the character, so they're like, well, we'll give you a node that automatically figures out who the character is that has this animation, right? So what we're going to do is we are going to pull this out. And we are going to try to get the speed, right? We need the speed of the character, so we'll say get velocity, right? So we'll get the velocity of the character, which is how fast he's moving. And there's this idea of event blueprint update animation, which runs basically on every update of the animation frame, right? So that's where we're going to start things off, and we are going to say set speed, right? So this speed variable, we're going to just copy from here, and this velocity that we pulled out, what we're going to do is we are going to check if this velocity, this velocity is a vector, right? So we want to get vector length, right? Let's get vector length. Get length. Whoops, not get path length. I want to get vector length. Just give me a second. So get vector just vector length, that's it, right? So sometimes some of these commands can get confusing, which is why you have to try a couple of times, and with practice you'll get better and better. So yeah, so I want to get the vector length, and I want to set that as the speed of the character. So I'm just going to press compile, I'm going to press save. Right? So essentially we're feeding into the speed and saying that update the speed from the actual velocity of the character, and the velocity of the character we're going to get from the owner of the pawn. Now sometimes this might be invalid, right? The animation blueprint might be running, but the character or the animation might not have any parent character. So just to make sure that there is actually an owner, we're going to use the isValid node, this isValid node, right? You don't necessarily have to do this, but it's good practice, right? So I'm just going to take this try_get_pawn_owner, and I'm going to drop it into the isValid node to make sure that the blueprint that's running this, the third-person character, actually exists and is in the game. So then I'm going to compile, I'm going to save, and we basically have set the speed. One thing I want to do, just to show you guys what's happening, is I want to print a string with the speed. Right? I just want to make sure you guys see that there's a speed and it's being updated. So speed is 0, and as we move around, the speed is moving to some different variable, and it's running every frame, as you can see, and the speed is updated every single frame, We don't need to output that anymore. We don't need to print the string anymore. We know the speed is being calculated perfectly. And what we're going to do is in our new state machine, we're going to say, well, we know the speed. So when does the player go from idle to walking? We want the player to go from idle to walking after the speed is anything more than maybe 5 or 10, right? So I'm going to double click this thing here. I want to see what I double click. This transition rule, right? This symbol here, double click that. And what we're going to do here is we are going to take the speed, right? We're going to get it. And we're going to say if the speed, so we'll do a branch. Actually, what we'll do is we'll do vector greater than, actually float greater than float. So if this speed is greater than 10, or maybe let's make it 5, then you enter the transition, right? Only then you go from idle to walking, right? And what we're going to do in walking, we're going to double click walking, and we will choose a simple walking animation, and we'll drag this in to the output animation pose, right? Compile, and as you can see, you know, we have this player. He's not changed at all because obviously his speed is not above a certain limit, right? So we're just going to save, and we'll press play, and as you can see, nothing happens. But when you move, the player is walking. How brilliant is that, right? It works. Obviously, when you jump, the player is still walking because the speed is still high, and there's no rules, there's no way we're checking for the jump. So we got the walk, and it works really well. But when you stop walking, the guy is still walking, right? Because once you enter the transition rule, there's no way for you to transition back. How does this anim graph, this state machine, know to go back from walking to running? So what we'll do is we'll drag another line back, right? And we'll say, we'll drag one line back, and we'll add a transition rule saying, well, if the speed, we'll say get speed is float lesser than float. If the speed is less than, let's say 4, right? You enter transition. Just enter that transition. We can actually set this to 5. That shouldn't be a problem, right? So you can enter transition as long as the speed is less than 5. Then you know what you should do? You should come back into the idle state because the guy is no longer walking anymore. So I'm going to press play, and you can see this. And as soon as I stop, you can see the player stops. That's it. The player's gone back to the idle state. So as you can see, we're slowly building up our animation graph. We're slowly making sure that when the player stops, the animation stops too. And this is the advantage of the state machine, right? The animations, and I want to kind of reiterate this point, they're so disconnected from the actual blueprint of the character. So whatever is determining the character's speed, his jumping, his input, that's all completely disconnected from the animations. The animations are happening separately from all of this, which is what is so cool about Unreal. They've managed to make, you know, the designers can work in the design while the coders can work on the code. It's beautiful, but we're experts, or rather we want to be experts. So we want to kind of know the entire engine inside out. So that's it for this episode. In the next episode, we'll go into making some more complex animations, and we'll make sure that if we're walking fast enough, we start running. Catch you in the next one.